Hello everyone, I hope you're all doing very well. Welcome back to the PlaneMaker tutorial video series. In today's video, I'm going to go over how to modify weight and balance properties of your aircraft, and also how to create and modify landing gear. So without further ado, let's get right into it. So the first thing you're going to want to do is bring up your aircraft in PlaneMaker, and first thing you'll notice is that if you go to wireframe view, you'll see this kind of black dot looking thing, and you notice that it just stays a constant point no matter how much you zoom in on it. And this point right here is your aircraft center of gravity. Before you've created anything else, there will only be one point, and that is the center of gravity on your aircraft. And so obviously if the center of gravity of the aircraft is right here, and the center of lift of the aircraft is somewhere around here, when we try to induce a pitch moment, we're not going to really have an easy job of doing that because the center of gravity is going to be over here pulling down while we're trying to move all of this up. So if you're just creating your aircraft for the first time, you're definitely going to want to position your center of gravity. So you do that under Standard and Weight and Balance, and right here is Center of Gravity. So now where your center of gravity should be really depends on the configuration of your aircraft, but as a general rule of thumb, I like to put it, at least for starters, about a third of the way down my wing's chord line. Just kind of as a rough estimate. And that means that I'll end up with a hopefully statically stable aircraft, which is usually a good thing unless you're trying to make a unstable aircraft, which we'll talk about later. So you can see here we have the three axes: longitudinal, lateral, and vertical. And so you can see, oh no, sorry, no, that's not what this is. So these are, so this is the maximum forward position that your center of gravity can be on the longitudinal axis. This is the, the first box is the minimum longitudinal position of your center of gravity. The middle box is the default longitudinal position of your center of gravity. And the last box is the aft limit of your center of gravity. And now, just for starters, I'm going to modify the default here, and I'm going to put that right about there. 25 feet seems reasonable. Now you can't change where your center of gravity is on the lateral axis, just because obviously if you did that you'd not have a very easy to fly aircraft at all, but I am actually going to move my center of gravity down 1 foot. And so that is how you adjust where your center of gravity is. Now, you may remember in the first video when we first created this basic aircraft, you entered an empty and a maximum weight in the weights tab. Now these are just placeholder values, and up until this point they really just haven't been meaning anything, but now we want to actually give our aircraft a set of weights so we know that it'll give us reasonable performance in X-plane. So the first column here is empty weight. Now empty weight, obviously, is the weight of your aircraft when it's not carrying any fuel or any payload. So no passengers, no nothing, no fuel. This is what it weighs on the ground with nothing in it. And so my aircraft is about 50 feet long, and it's got a relatively long wingspan. I'm just going to put in 21,000 pounds as my empty weight. And now, what I'd recommend doing is, if you're not super familiar with what aircraft weigh, just try to find an aircraft on the internet that has a similar size to whatever you're making, and give it an empty weight, something like that. Now the next one that we are concerned with is fuel load. Now fuel load is really up to you, depending on how much range you want your aircraft to have, but just be aware that more fuel means more weight, and more weight means your engines need to work harder to move your aircraft. So just keep that in mind when you're assigning a fuel load. I'm going to, again, I'm going to say 10,000 pounds for my fuel. And for these boxes, you can actually click in them and type in numbers to modify their values, which is nice, especially if you want precision. Alright, so now the JATO weight is the weight of the fuel of the jet-assisted takeoff rockets. And now this is something that I don't really think most of you will need. If you do want to see how to create a JATO system, just come to office hours on a Friday and I can help explain that to you. Jettisonable load is the load that your aircraft can carry that can be dropped. So if you're making something like, if you're trying to model the Stratolauncher, you'd enter a weight here for whatever you're dropping, and then you'd say other aircraft. If you're making a firefighting aircraft, you'd make it be a weight of water or fire retardant. And if you were making a helicopter that was going to be carrying other things, you'd say jettisonable load is slung. Right, now the next value here is the maximum weight, or the maximum, so this is just the maximum allowable weight that your aircraft can be. X-Plane will not let you increase the payload or fuel of your aircraft past this value, no matter what. And so what I generally do is I add up my empty weight and my fuel weight and any other weight I have, and then I put my maximum about a third above that, just kind of as a placeholder until I actually test and see how much my aircraft can reasonably carry. So in this case, I'll just say, I'll say my maximum weight is going to be 40,000 pounds. Now the weight shift weight, we don't want to do this unless you're making a hang glider. And I'm just assuming that no one is making hang gliders. Again, if you want to learn what these other two do, just come to office hours and I can help you figure that out. So now, for center of gravity, I would recommend you give yourself about 2 feet of adjustable leeway in either direction, just for starters, until you figure out what works best for your aircraft. So just be sure to enter those values in as well after you've put in your default, which is this metal one. So now you may have noticed that the view of my aircraft in PlaneMaker has changed a bit. So when you rotate your aircraft around, it rotates around the center of gravity by default. And so now that I moved that, now I'm kind of rotating around the whole aircraft more evenly, which is another nice thing. So now let's go back to weight and balance. And now we've given ourselves a fuel load of 10,000 pounds, and right now if we were to load this aircraft into X-Plane and drop it from a B-52, we would be able to control this aircraft as a glider, and it would perform reasonably well according to whatever X-Plane thinks its flight model should be. But what this does not have is fuel tanks, and it doesn't have engines either, so if we want powered flight, we're going to need both of those. Engines will be the next video, so for now we're just going to set up our fuel tanks. Fuel tanks can be set up in the tab in weight and balance called tanks, obviously. And you can see here you have a whole bunch of values here, and the rest is completely blank. So you can have as many as 9 tanks, and you can specify how much of your fuel is in each of those tanks. If you have multiple different tanks with multiple different amounts of fuel in them, they all need to add up to 1. And if you were to say have, like, if you wanted 2 tanks, you could put one in your left wing, one in your right wing, or you could have a center line tank in your wing box and then wing tanks, however many you want. Just for simplicity's sake, I'm going to do 1. So I'm going to say the ratio of the total amount of fuel in tank number 1 is going to be 1.0. And then again, we have our 3 positioning values on the 3 axes. So I'm just going to make this be the same as my default center of gravity, which is 25 feet. And then I'm going to lower it by a foot just so it's at the same spot. And that's basically it. That's all you have to do to make fuel tanks. The one other thing you need to do is to set a fuel pump pressure. If you do not do this, fuel will not be pumped out of your fuel tanks, and your aircraft's engines won't get any fuel and they won't work. Doesn't really matter too much what you put in here unless you're doing detailed systems modeling, which most of you won't be doing. So I'm just going to say 20 psi for now. That seems to have worked for me in the past. And that's all for weight and fuel. So right now, if we were to... The only thing left really to do to have a controllable, flyable aircraft would be to add engines. Engines are pretty complex, so I'm going to leave that for another video. But now we're going to talk about how to create landing gear. Unless you're building a flying boat, which most of you probably won't be, you're going to want some landing gear. And so landing gear are created and modified under standard landing gear. Surprise, surprise. And you can see you have 10 different slots here, and in each of these columns you can define the values that'll determine what your landing gear look like and where they are and how they behave. So you can see there's the little dialog box that determines what the type of your landing gear is. So you can have no landing gear, you can have skids, you can have a single, so this is a single wheel. You can have 2 lateral, which is 2 wheels with lateral separation, and 2 long, which is 2 wheels with longitudinal separation, then a 4 truck, which is basically 2 sets of 2 laterals with some longitudinal separation, then a 6 truck, which is 3 sets of 2 laterals, and then a 2-4, which I can maybe show you later because it's kind of tricky to describe, and then a 3 lateral, which is 3 wheels with lateral separation. So I'm just going to say I want 2 lateral, maybe no, I'll have 2 lateral on my nose wheel and then 2 larger single wheels. So the 2 values that you need to input to determine the size of your landing gear are the radius of your tire and the semi-width of your tire. So semi-width is from a halfway point of the tire to the exterior of the tire, and radius is obviously the radius of the tire. So for the radius of my nose wheel, I'm going to say it'll be 5 feet, no, sorry, half a foot. That looks a bit small. I'm going to say about 0.8 feet. And now you see I've got this very thin wheel in the front of my aircraft at the origin. So now I'm going to give it a semi-width so it has thickness, and there you go. Now I've got a landing gear. When you first create them, it might be a good idea to use a wireframe view depending on where your fuselage is, just because they may be covering your landing gear. And so now you can see I've got one here. Now I'm just going to do the same for my other 2. I'm going to give them a radius and semi-width. I'll do 1.3 feet for these because I want them to be a bit bigger, and then I'll make them be a bit thicker. Semi-width of 0.3 feet. And now I've created each individual wheel, but I am not done yet at all. So right now, if I just position these wheels, they would just be where they are, and I wouldn't really have a whole bunch of control over how to retract them. So you would probably also want to create legs or struts for your landing gear, so that is defined in leg length. And if I give my nose wheel a leg length of 4 feet, you can see now it has a strut. Now it's visible outside of the fuselage. So I'm just going to go ahead and position my nose wheel right away, just so it's out of the way. And positioning is done in these 3 boxes here, which you should be familiar with by now: longitudinal, lateral, vertical. And because this is a nose wheel, I'm going to move it to about there on my fuselage, and I'm also going to move it down, so it's mostly up with a little bit of it down. Okay, now I've got my nose wheel all set up. Now I'm just going to do the main landing gear. So for these, I'm going to give them a leg length of 5, no, let's just do 4 feet for these as well. Right, so now that I've created a leg length for each of my main landing gear, I'm going to position these as well. Except now for the main landing gear, this is a pretty important step. You want to position them so they're just behind your center of gravity, so that when you rotate your aircraft, it'll rotate on your main landing gear. If they are in front of your center of gravity, your aircraft is going to tip over backwards. That's not very nice. So I'm just going to make sure that they're maybe 28 feet. That seems reasonable. Now they're behind my center of gravity, and they will allow me to rotate the aircraft. And again, I'm going to position these vertically as well. And now I have a decision to make. So I can either keep these attached to the fuselage or attach them to the wings. I think for the sake of this example, I'm going to attach them to, I'll just show you how to do both. So this is where you're going to want some lateral separation. So I'm going to make this one be on the left. I will move it out, let's say 6 feet. No, 5 feet. Then I'll do the same to the other one, giving it a positive value. And now this part is, this is a bit of a tricky thing to do if you have a really thin airfoil. But what you want to do is you want to position your strut so that it's about halfway up your airfoil. So I'm just going to adjust these on the vertical until I'm happy with where they are roughly. So 1.1 feet looks like a good spot for these. So now I've got my landing gear created. And you can see that this is starting to look more and more like an actual aircraft and not just a tube with skinny little wings. I'm actually going to make these legs a bit longer just to compensate for how much I had to raise them. And there you have it. So now this is an aircraft that you could drop from a bomber, glide around for a while in, and safely land. But after you've landed, you would not be able to steer your aircraft at all, or retract your landing gear if you wanted to take off again once we had engines. So to make your landing gear retractable, what you need to do is you need to go to the Gear Data tab, and then say Gear is retractable. And we're going to go back to the Gear Location tab in just a moment. Another important thing you'll want to set here is your nose wheel steering. So there are three really important values here. Your low speed steering and your high speed steering. So at a low speed, you want to be able to adjust the position of your nose wheel quite a bit so you can turn in a pretty tight circle. I usually say 70 degrees. It'll depend on the position of your aircraft's landing gear though, so your mileage may vary with that. And then once I get going at a high speed, I want a relatively low amount of authority over where this is pointing, just so I don't go careening off the runway when I'm trying to land and I make small rudder adjustments. So I'm just going to say 5 degrees there. In the transition speed is where it'll lock out your low speed steering travel and only let you control it by this much. So since you should never really be taxiing any faster than 30 knots, I'll just say 35, because once I'm going faster than that, I'm either about to take off or I'm still in the process of slowing down after a landing. Now this value, I don't really need to worry about. Everything else in here, this stuff is all pretty useless for your purposes. You may want to consider these values here, which allow you to determine the longitudinal and lateral separation of your wheels. So if I just go back here and make this a 2 lateral and I'll make this one a 2 longitudinal, these values will allow me to move these farther apart. And then likewise for the longitudinal gear. I just leave these at 3 because it's the default, and if you don't have a specific look in mind, it's kind of weird. So I'm just going to make those back to what they were originally. So now we've given our gear the ability to be retractable, so now we just need to define the values that'll tell them where they go when they retract. So there are a whole bunch of angle values here that you can set for each of your landing gear. There's an extended angle value for the longitudinal and lateral axes, and then there are retracted values for both of those. So the longitudinal angle extended is the angle that your gear will be at when they are extended. So if I put in 20 degrees or 40 degrees here, when my gear are extended, they would extend to 40 degrees and they would retract to 0. I'm going to leave this at 0. You may want to do this depending on how your aircraft is looking. It's really a matter of personal choice, at least for the nose wheel. Now for my longitudinal angle when the gear is retracted, I can say, let's say, negative 100 degrees, so it'll tilt back and up into the fuselage, and it'll be completely indivisible from view when it's fully retracted. If you can see your landing gear outside of your wings or fuselage when they're retracted, they will have an aerodynamic effect on your aircraft in X-Plane, so just be aware of that. They will create drag. So now you can see that one's retracting properly. And because this is my nose wheel, I'm going to check this box down at the bottom that says this gear steers, because obviously I want that one to steer. I'm not going to make my other two steer, and I'm not going to give them fairing because that is that's something we'll maybe get into later, depending on how I feel about it. And so now for these landing gear, I want to give them lateral degree values for their retraction. So I am going to say this one retracts to negative 90, positive 90, and this gear retracts to negative 90. Now you can see for these they are retracting, but they are colliding with each other inside the fuselage, and they're not fully hidden from view. And if you want to avoid having your gear colliding with each other when they retract, one thing you can do is you can make them compress a bit while they retract. So this value here is a value in feet for how much your gear can compress. I'm just going to say each of these main ones can compress by 2 feet, and now you can see they're not smacking into each other when they retract. So, but this is still not an optimal gear configuration for me because part of my struts are hanging out of the aircraft. This will create drag. Now you can get around this by making your gear skinnier, but skinnier gear are less grippy and less stable, so you'll skid around a lot more when you are trying to move at high speed on the ground. So what I'm going to do actually is I'm going to reset these values and these to 0, and I'm going to actually put my landing gear in the fuselage. And so I'm just going to make these be 1 foot away from the longitudinal axis. And now by default you'll see they're looking like this. This is not a very stable configuration. Your aircraft will tip over if it's even remotely windy. So we want our gear to be positioned outwards of the fuselage. And to do this, we can give them a lateral extended angle. So for this one, we can say maybe negative 40 degrees. We can say positive 40 for this one. Now you can see when they are extended, actually I'm just going to switch back to still controls. When they are extended, they're out here now. This is much better. This is much more stable on the ground. So I'm going to keep it at 40 degrees. One thing this is not going to be great for is this will have a very, very positive ground attitude, and if I draw a line kind of through where these are going to compress to when they're on the ground, you can see that I'll be dragging my aircraft's tail around on the ground. Generally you don't want this, because, well, for obvious reasons you don't want to damage your aircraft on the ground. So I'm going to make these legs longer until it looks like my aircraft will sit nicely on the ground. And there you go. So now they're only retracting right now to 0 degrees in the lateral axis, so we're also going to give these a longitudinal And I'm going to, sorry, I'm going to go back to landing gear. And I'm going to say the longitudinal retracted angle of these is going to be 100 degrees. And now you see they're swinging in and up into the fuselage. And they are completely out of the way. They will have no aerodynamic impact on my aircraft when they are retracted. And that is how you make your landing gear. Just for fun, I'm going to show you what some of these other types look like. So a 4-truck looks like that. You've got a 2x2 configuration. That's a 6-truck. So the 777 has a 6-truck, 767, 57, A320, no sorry, A330, 40 have a 4-truck. 777 and E380 have a 6-truck. Here's a 4-lateral. I can't think. Oh no, sorry. The AN225, I believe, and the C5 Galaxy, I think, as their nose gear, they have a set of these. There's also these 2 4-trucks. Some very heavy military and cargo aircraft have these for the main gear. And then there's a 3-lateral. I believe the Blackbird has this on its main landing gear. So I'm just going to keep these as single. And yeah, there you have it. That's how you make landing gear for your aircraft. Yeah, so I hope you found this video helpful. If you have any questions about any of the topics in this video, please come to office hours on Fridays, and I will try to help you out as much as I can. Yeah, so in the meantime, good luck with your aircraft, and I will see you in the next one.